Have you ever really stopped to think about it? How something smaller than your fingernail can power literally everything from your phone to artificial intelligence? It's kind of mind-blowing. Well, you're not alone in wondering. So in this explainer, we're going to pull back the curtain and give you a super clear roadmap into the fascinating world of chip design. I mean, it's a wild thought, isn't it? The phone you're probably holding right now, the AI that's literally shaping our future, it all comes down to a technology called VLSI. You can think of it as the art of packing just an insane amount of brain power into a space that's almost too small to see. So what even is VLSI? Well, let's try an analogy. Imagine a chip is like a huge, sprawling, microscopic city. Every single transistor is a building, and the wires, those are the intricate network of roads and highways connecting everything. VLSI, then, is the art and science of being the master city planner for this whole tiny metropolis. All right, you ready to dive in? Here's our game plan. First, we'll build up your learning foundation with the absolute essentials. Then we'll check out the two main worlds you can specialize in. After that, we'll walk through the entire blueprint of how a chip is actually born. And finally, the best part, we'll show you how you can get your hands dirty with some powerful free tools. Let's go! Okay, so every single beginner asks the same question, right? Where in the world do I even start? The answer is always the same. You've got to build a solid foundation first. So let's look at the absolute must-have. So what's the starter pack for a chip designer? What do you really need to know? Well, engineers who do this for a living pretty much all agree it boils down to these four things. First up, digital logic. This is like the basic grammar of how circuits think. Then you've got your electronics basics. That's the physics behind how all those tiny little parts actually do their thing. Next, you got to learn a hardware description language, an HDL. Verilog is a great place to start. It's literally the language you use to write the chip's blueprint. And finally, a scripting language like Python. Trust me, you'll need it to automate all the boring, repetitive stuff. Nailing these down isn't just a suggestion. It's absolutely crucial. And hey, don't just take my word for it. As one user in the VLSI community on Reddit put it, mastering these fundamentals does way more than just teach you the ropes. It actually acts as a compass, helping you figure out your own path in this huge and really exciting field. Okay, so once you have that foundation, you're going to hit your first big fork in the road. And this is where you have to decide, are you a front-end engineer or a back-end engineer? Let's break down what that actually means. So this is the classic architect versus builder split. You see, front-end is all about logic and functionality. It's about designing what the chip should do. Back-end, on the other hand, is all about the physical implementation, figuring out exactly how to build that design on a piece of silicon. One is pure abstract design, the other is all about concrete reality. And what's really cool is when you get into the nitty-gritty. For the front-end architects, you see skills like RTL design. That's the actual coding of the chip's logic. Then for the back-end builders, you see things like floor planning, which is literally designing the physical layout of the chip's city. These aren't just buzzwords. These are the actual skills, the real tools, and the job titles you'll see out there in the industry. So it really makes you think, right? Which one are you? Do you get a kick out of solving abstract logic puzzles and writing really elegant code? Or do you love the challenge of fitting all the pieces together perfectly in the physical world, almost like a high-stakes game of Tetris? Just knowing the answer to that is a huge step in finding your place. Now, no matter which path you find yourself leaning towards, every single chip on the planet follows pretty much the same fundamental creation process. This is the master blueprint, the step-by-step guide that takes an idea from just a thought into a real piece of technology. Okay, so it all kicks off with the spec. That's the document defining exactly what this chip needs to do. From there, the front-end architect gets to work writing the RTL code. That code then goes through a process called synthesis, which basically turns it into a giant list of standard parts. Then the back-end builders take over with physical design, laying out that entire microscopic city. After tons and tons of testing and verification to make sure it all works, the final blueprint, this file called a GDS2, gets sent off to the factory to be built for real. Now, that synthesis step, it's the real linchpin here. This is the critical moment where the architect's high-level code gets translated into a concrete shopping list of electronic parts for the builder. You could say it's the essential bridge that connects the world of abstract ideas to the world of physical reality. Okay, let's tackle the one question that's probably on every student's mind. This all sounds amazing, but how could I ever afford the professional software to actually do any of it? Well, you're in luck because the game has totally changed. So, the hard truth is that professional chip design software can cost a fortune. I mean, we're talking licenses that run into the thousands, sometimes even millions of dollars. For decades, this was like a massive wall blocking students and hobbyists from even trying. But now, thanks to the open source movement, that wall is coming crashing down.
And this right here, this list, is why it's such an exciting time to get into this. I mean, look at these. These are not some watered-down for students-only toys. No way. A tool like OpenLane lets you run the entire design flow, from your very first line of code all the way to the final file you'd send to a factory, just like a professional. And then you have something like Google's Sky 130 PDK, which is a real open-source process design kit. That means you can design a chip for an actual manufacturing process. This level of access for someone just starting out, it's a total game changer. It's absolutely revolutionary.
So there you have it. We've laid out the foundational knowledge you need. We've explored the two big career paths of the architect and the builder. We walked through the entire chip creation blueprint, and we've uncovered the amazing free tools that put all this power right at your fingertips. You know, every piece of technology that has ever changed the world started as an idea, and then as lines of code. The knowledge is out there for the taking, and as we've just seen, the tools are now open to everyone. So the only real question left is, what are you going to design?